Hello everyone. In today's lecture of chapter Structure of Atom, we are going to study about atomic spectra. So the first point that we are going to study, that is, what is a spectrum? Spectrum is when a solid is heated to incandescence, means when it starts emitting the light, means you can say that now when it starts glowing, so it emits light. On passing this light through a prism, a band of color is obtained. It is a similar you can say effect like sunlight gives a spectrum of 7 colors that we know as vigor. Each color is characterized by a range of wavelengths or frequencies. Like we know that violet has the least wavelength, red has highest wavelength, whereas the frequency of violet is greatest, whereas of red is frequency of red is smallest. It implies that sunlight already consisted of these wavelengths mixed together, which we see as white light. The prism has simply separated and emitted them in a sequence. Earlier it was used to believe that prism created the light, means when people didn't know this thing that white light has the constituent of 7 colors, they used to think that prism is a device which creates 7 light, but it was came to know that later on that prism is not creating the light, means 7 colors of light. The white light has 7 constituent colors which is just separated by the a prism. Now, so very important terms after these, that the separation of constituent wavelengths in a definite sequence by a prism is called dispersion. As we have studied this as vigor, means these colors of these colors, or you can say spectrum, is obtained in this sequence only. This will never happen that red will come in between. Okay, and generally we have seen this thing as the effect of rainbow. In the rainbow, these colors are present in this order only. So the dispersion of light is the separation of constituent wavelengths, or you can say constituent colors of the white light in a definite sequence. And the series of color bands is called. So as we have seen that the series of color bands is called spectrum. Now, thus the representation of intensities of the constituent parts of radiation wavelength wise, frequency wise, or wave number wise on a photographic plate or on paper is regarded as spectrum. Okay, in the spectrum of an incandescent solid or sun, the color bands are adjacent and merge with each other. Such a spectrum is known as continuous spectrum. You must have seen that like rainbow. In rainbow, the colors, all the 7 colors, they get merged with each other. You cannot observe the distinct lines between the 2 colors. So that is called continuous spectrum, because one by one they keep on coming. So now this is due to the collective behavior of large number of interacting atoms, because millions of atoms are present there and they are continuously emitting, or you can say producing the spectrum. So that is why the continuous spectrum is produced by this sun or any incandescent solid. This pic shows you the spectrum of light. At the bottom it is visible spectrum, and the blue strip you see is a complete electromagnetic radiation spectrum from gamma rays to the radio waves. After seeing the basic spectrum explanation, let's study the what is atomic spectra. That is the main topic. The spectrum obtained on account of the characteristic behavior of an individual atom. Like you know that the atoms of each element is different from the other. So that means for every atom the atomic spectrum will be different. So it is a characteristic property of all the atoms. Atomic spectrum is also of 2 types. That is emission spectrum, which is also called line spectrum. So in the emission spectra, what is how we can get and what are the properties? It is the spectrum of radiation emitted by an atomic species analyzed by a prism. Means any atom which has emitting some energy out, if we study that energy by using a prism and some other instruments, then we get the spectrum which is called emission spectrum. it contains distinct bright lines. Okay, I will share a pic with you about the emission spectrum, that how it looks like. Now, a molecular species also give the same emission spectra, but it contains group of lines called bands. Because we are studying here the distinguished atoms here, so that is called atomic spectra. But when we take any molecule, in a molecule like for example carbon dioxide, we have 3 atoms of 1 carbon and 2 of hydrogen, so they must be giving the band of colors. Okay, so that is called band, not a single line. Now, it can be obtained by, what is the process to obtain any atomic spectrum? That is, first by heating the vapor of an element at very low pressure, and then again which is the emitting energy, that is observed again by the prism and the spectrometer. Second, by passing electric current or discharge through an elemental gas at low pressure, like we have studied in the cathode ray tube. And analyzing this emitted radiation by a prism, by both methods, that whatever energy is emitted, that we can analyze by any prism. The instrument used for recording the spectrum is known as spectrometer or spectrograph. The atomic spectrum is a characteristic of an element. Okay, as I have already told that all the elements and the atoms present in them have a specific spectrum than the other ones. So very important point, that how important is the atomic spectrum. Rubidium, cesium, thallium, scandium, gallium were discovered by atomic spectra study. Now, the atomic spectrum of an element always differs from the spectrum of some other elements. Okay, like these elements you can see are all the different elements, and they are discovered by the study of their specific spectrum and comparing with the other atoms. This pic is showing 2 spectrums, continuous spectrum, that is Vibgyor, and the below is emission spectrum, that is obtained by the emitted lights from the atom. The bright lines are showing the emitted radiations of different wavelengths. Have a look of some examples of atomic spectrums of different metals. The second type of atomic spectrum is absorption spectra. The spectrum obtained by the selective absorption of certain wavelengths by a substance from the electromagnetic radiations to which it is exposed is known as absorption spectra. That means like if any metal is given some energy, and then the energy, some energy will be absorbed. That was seen in the seen that when it will whatever energy any metal will absorb, the same energy it will emit also, right? So that is given in the emission spectra. Here in the absorption spectra, the energy which is absorbed by us of a certain wavelength by any substance, so from that electromagnetic radiation to which it is exposed, clear? So that means the remaining part of that spectrum gives us the absorption spectra, and there will be the dark lines what energy is absorbed by the given substance. Now, when electromagnetic radiations are passed through a substance containing atomic species, the atoms present in it may absorb certain characteristic wavelengths. Okay, like already I have told. On analyzing the emerged light by a prism, dark lines are observed in place of observed wavelengths. Absorbed wavelengths means the wavelength which is absorbed at that place we will get dark lines. Okay, and the other places we will get the specific colors. It is also a characteristic of atoms giving absorption spectra, means both are the same properties, characteristic properties. In fact, the dark lines in atomic absorption spectrum appear exactly at the same place where the bright lines appear in an emission spectrum. Means in the emission spectrum, the wavelengths which are shown by the colored lights, at the same places, if we for the same metal, if we repeat the absorption spectra, there we will get dark lines. So this is the difference between emission spectra and absorption spectra. This pic shows the absorption spectrum of a sample. You can see the light is passing through the sample, then through a prism, and dark lines are shown that the absorbed emission from the sample, and the others are colored lines. This pic shows the emission spectrum and absorption spectrum for the same sample of element. Now, as you have understood about emission spectrum and absorption spectrum, let's study about the emission spectrum of hydrogen atom, because this was the experiment of Niels Bohr, on the basis of which Rutherford's atomic model got discarded, and then Niels Bohr produced his atomic model. So let's study I will explain in very brief and important points. That is, hydrogen is the simplest of all atoms, as we know, because it contains only one planetary electron. Planetary electron means like the planets revolve around the sun, so there is only one electron which is revolving around the nucleus in hydrogen atom. It gives a very simple atomic spectrum, whereas other elements give a complicated spectrum. As we know that in other elements there are other levels, means the more orbits are there, more number of electrons are there, so that is why it is complicated than the hydrogen. So hydrogen is a very important element to study about the atomic spectrum of the elements. The atomic spectrum of hydrogen can be obtained by analyzing and recording of the radiations emitted by the excited atom of hydrogen. Okay, for example, like if I say that, if you can see this diagram, if this is a nucleus where hydrogen atom is there, and in the orbit hydrogen, one electron is revolving here, and if it gets some energy, okay, like in the photoelectric effect you have seen, so when it gets some energy, then what will happen, this electron will go in the higher level of the energy. This you can see like this this is called excited state. Okay, this is called excited state. You can see here, like it is called excited state. So when it will go in the high energies, it can be in the more energies also. If we give more energy to it, it may go to the higher levels also. But if we, by the theory, or you can say by the experiments, it was proved that no atom in this world tries to remain in the excited state. It always tries to be in the ground state, means at the level it is originally at. So whatever electron will absorb energy and will go in the higher states, that will definitely emit some energy and will come back in the original ground state. This is called ground state. Now it can be done in the stepwise also, means if the small amount of energy is given and a small amount of energy is released, then it can go one by one atomic states, from one excited state to another and then to the ground state. But if the more energy simultaneously is given to us, then it may happen that it will go to the higher levels directly and will maybe come back also in the ground state directly. So this is the diagrammatic representation how the you can say the radiation and absorption of energy can be done by the hydrogen atom. Now let's come to the theory part. That is, as you see, for this purpose, what we do, the hydrogen gas is taken in a discharge tube at low pressure. Then on passing the electric discharge, the radiations emitted which are passed into a spectrometer. Okay, a spectrometer is equipped with a prism that analyzes the radiation wavelength wise or frequency wise. Then spectrometer uses a photomultiplier or amplifier and records the spectrum of all regions of radiations. Okay, I want to clarify all the points again. Like here, on passing the discharge tube, the radiation is emitted and passed through the spectrometer. A spectrometer is a machine which records the all the radiations and the, you can say, the spectrum part. Then it is equipped with a prism which you can say disperses all the radiations into the according to their wavelength or the frequency. Then spectrometer is given with the photomultiplier or amplifier, because it is means only by using simple spectrometer we can only observe the spectrums of the visible range or the limited ranges, but photomultiplier and amplifier make us able to record the spectrums of all regions, like from gamma regions to the radio regions, which generally which are not there, means from at least from ultraviolet regions to the infrared regions. Okay, let's study the atomic spectrum of hydrogen in detail. Hydrogen spectrum, it consists of a large number of sharp lines spread over ultraviolet, visible and infrared regions of electromagnetic spectrum. Each line corresponds to a definite wavelength or frequency characteristic of the atom. That I have already said that whatever energy is absorbed, that is of a particular wavelength wise or their frequency wise or wave number wise. The lines present in the atomic spectrum of hydrogen have been grouped into 5 series that are as follows. The first is Lyman series, that is from the ultraviolet region, and the wavelength is from 920 to 1200 angstroms. Then is Balmer series, which is from the visible region from 4000 angstrom to 6500 angstrom. Then Paschen series, bracket series and Fund series all are from infrared regions, and these are the wavelengths of the particular regions. Now in 1885, Balmer showed that the wave number of spectral lines present in the visible region in hydrogen spectrum are given by this formula. Nu bar is equal to 109677 bracket 1 by 2 square minus 1 by n square centimeter inverse, where n is the integer. It is greater than or equal to 3, means greater than that value of 2, because Balmer could only explain the visible region of the hydrogen spectrum. But later on there was a scientist named Rydberg. Rydberg showed that wave number of spectral lines present in spectrum of hydrogen can be given by this formula, that is nu bar is 109677 bracket 1 by n1 square minus 1 by n2 square centimeter inverse. That is n1 is 1 2 3 4 any kind of integer, and n2 is 1 more than the n1, that is n1 plus 1, means if we put n1 1 then n2 will be 2, if we put n1 2 then n2 will be 3, and so on. This number 109677 is a characteristic of hydrogen atom known as Rydberg constant. So on the basis of these spectrums you can easily understand that once more I want to explain it here, that like when the energy was given to hydrogen atom and electrons got to the excited states and came back to this. So on the basis of this, the Rutherford's theory got discarded, because according to his theory, when he said that electron is revolving around the nucleus, and it was said that by the Maxwell's theory that if the charged particle is revolving in or moving in a circular path, it must radiate some energy, and finally it will go down to the nucleus and it will collapse and the atom will be finished. But it doesn't happen. So first of all, that Rutherford could not explain the stability of the atom. And the second point which we have studied here till now, that when the from the hydrogen we have seen that electron is going from one excited to another excited state and coming back also from one to another, or directly from the higher to the lower region. So that showed that the energy released or emitted by the hydrogen atom was not continuous, it was discontinuous. Whereas in the by the theory of Rutherford, because hydrogen is continuously, this electron is continuously releasing energy or emitting energy, so that should go with the continuous spectrum. But we do not get a continuous spectrum, which should be from here, continuous spectrum, but we get a discontinuous spectrum from here. Okay, discontinuous spectrum. So this proved also that Rutherford's theory was wrong, which was later explained by the Niels Bohr's theory. So just the points of the failure of Rutherford, that it couldn't explain the stability of atom, as well as it could not explain the atomic spectrum of hydrogen. In the next video we will study about the hydrogen atomic spectrum explained by Niels Bohr theory. Thank you. This pic is representing the hydrogen spectrum obtained from the different regions, ultraviolet, visible and infrared, in series wise.